Good morning, good afternoon, 7.2, multiplying powers with the same base, day 2. Alright, I can multiply monomials using the properties of exponents. So, first thing we're going to be working with is expressions with rational exponents. So now maybe a x to the 1/4 power example. So m over n, the denominator will tell you how many times you will multiply a number by itself. And sometimes I like to, this can be changed to the 1 goes in here and the 4 comes out here. So this is just an example. So if I were to break this 16 3/2 up, this would be 1/2 plus 1/2 plus 1/2, right? When I have like bases, I can change it to, I could add their exponents. So I'm just kind of breaking down that 3/2 to 1/2 plus 1/2 plus 1/2. Now, the 2, what do I multiply by itself 2 times to get 16? Well, that's 4. So it would be 4 times 4 times 4, which is 64. Another way to show this would be if I did 16 and I brought the 2 out to here and the 3 goes here. The 2 is the index. This means square root. If I had a 3 there, it would be the cube root, meaning what multiplied by itself twice will get me 16, and then I multiply that by that number times itself 3 times. So the square root of 16 is 4, and then 4 times 4 times 4 is 64. Got it the same way as this one. This is the y. This might help with some. This might help with some. Okay, so let's do this one. 25. Again, we could do 25 times 25 times 25. Break it down that way because when we multiply like bases, we add their exponents, which would be 1/2 plus 1/2 plus 1/2, which would get us 3/2. Okay, first, what's the square root of 25? That would be 5 times 5 times 5, which that's 25 plus 5 is 125. Sorry, not plus, multiplied by 5. Again, I can bring my denominator out to be the index. So my index is 2, 25, and 3. So the square root of 25 is 5, and multiplied by itself 3 times or cubed, which would get me 125. Okay, an index is my number on the outside of the square root or the radical symbol. This is right now, this is a radical symbol. When I don't have anything written here, my index is 2. So what we've learned, square root of 81 is 9. But if I had something like this, and it showed a little 3 there, that would mean the cube root of 8. So what multiplied by itself 3 times would get me 8, which would be 2. This is just in my math in my head I can do. And this is like a 1 here. 2 and 1, because I can put anything to the power of 1 and I haven't changed it. So here, really, this is just saying the square root of 81. This can also be written as 81 to the 1/2 power. This and this are written the same thing. Okay, so 27, we can do 27 be the cube root, and then it would be squared. So the cube root, what multiplied by itself 3 times? So if I do 3 times 3 times 3, 3 times 3 is 9, times 3 is 27. So this is again math in my head. This equals 3, cube root of 27 is 3. I have to square that, which is 9. Okay, the other way I could do this is showing 27 okay, 1/3 added together gets me 2/3. So this is just a separate way to do it. The cube root of 27, or what multiplied by itself 3 times, will get me 27. Well, 3. So this is 3, this equals 3. 3 times 3 is 9. I get the same thing. And until we get comfortable with it, maybe we should do it a few different ways so that you can check your answer. Okay, 16. The index is my 4. The 3 is out here. So I'm going to do the 4th root of 16 first. So in my head, I need to figure out what times itself 4 times will get me 16. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So the 4th root of 16 is equal to 2. And then my 3 is up here, so 2 to the 3rd power is 8. Okay. Now what about this one? We want to just simplify this. So the only thing raised to the power is the c's. So we can rearrange this because they're all multiplying. So in multiplication, the order doesn't matter. So I'm going to move all my numbers to the front and then my c's to the back. So here I have 2 times 2, which is 4. I have like bases, which is my c, so I have to add their exponents. So 3/5 plus 1/5 is 4/5. So it's 4 times c to the 4/5 power. Here again, I have n raised to a power, so my like base is n. So I have to add these, so I'm adding 1/3 plus 4/3, which is 5/3. Again, adding fractions is a prerequisite. We have to be really good with that. We have to know that my denominator has to be the same. I don't add my denominator, I just add my numerators here. So 5/3. Okay, again, I have all multiplication, so I can change my order. I can put my b's out first, times b to the 4/9 times c to the 2/5 times c to the 9/10. And I'm going to change pencils because this one is just too thick. Okay, so here I don't have like bases, so I'm going to change this so that it's a 9. Well, I multiplied it by 3, so I have to multiply this by 3 to get to 6. So now I have b to the 10/9 power. I'm going to leave it as an improper fraction. And then c, again, I don't have like bases, so I'm going to make this a 10. I multiplied it by 2, so I multiply this by 2. So this would be 13 to the 10th power. If this was a number that could be divided easily, like if I got to, well, say 4/2, I would reduce that to 2. And then it would just be so-and-so to the 2nd power. So if it can simplify, I will simplify. If it's a improper fraction that you can't, don't change it to a mixed number. Okay, and our last one, we have a lot of stuff going on here, so I'm going to first pull out the things that I can. So 3 times 3, almost like terms, j to the 2/3 times j to the 1/6. So I got my j's. I forgot my 7, so I have times 7 times 7. Okay, my 2 7s, I brought my m to the 1/4 and then m to the 3 halves, sorry. Okay, so I can do this math. This would be 49 times 9, 81, 36, 44, 444. Maybe check my math on that one. So 441, and then j, again here, not like terms, so I have to make them, or not like terms, like denominators. So I multiplied this by 2, so I have to multiply this by 2, so then I have I'm going to add 4 6 plus 1 6, which gives me 5 6. And then m, again, not like denominators. Multiply this by 2, make this 2. So 1/4 plus 6/4 is now 7/4. And this would be my final answer, simplified as much as I can get. Okay, your assignment for 7.2 is page 430, numbers 21 through 29, odd, 33, 35, and 47.